All right, let's jump right in. We're going to talk about a single powerful idea today, one that might just be the hidden architecture of, well, reality itself. What if some of the biggest, most baffling mysteries in science aren't actually separate puzzles? What if they're all just different faces of the exact same underlying rule?
I mean, think about it for a second. Science is just full of these huge, nagging puzzles, right? You know the ones. Why does time only move forward? How can two tiny particles be instantly connected, even if they're on opposite sides of the universe? And why do we see the exact same beautiful patterns in galaxies and, say, seashells? What if these aren't separate questions at all?
I know. At first glance, that sounds crazy. They seem completely unrelated, right? One's about the spooky, bizarre connection between quantum particles, another is about the nonstop, irreversible flow of time, and the third is about the beautiful, elegant patterns we see in life itself. So what on earth could possibly connect all of them? Well, the claim is it's one simple rule. That's it. A single rule that underpins all of it. So today, we're going to explore this exact concept. The source material calls it the universal rule of return. Let's dive in. Okay, so to really get how this one rule can explain so much, we first need to grab our tools. We need to get familiar with its three essential building blocks. Once we have these down, we can start cracking open those big puzzles. All right, the first building block is something called return. This is the absolute foundation. The idea is, for anything to truly exist, and I mean anything from a tiny particle to a friendship, it can't just be a one-off event. It has to be a pattern that can repeat, a relationship that can happen again and again. Think of it like a melody you recognize. If you can't play it again, if it just happens and vanishes, well, the melody is lost. It didn't really exist as a thing. Okay, next up is coherence. Now, this is all about the quality of that return. So imagine you've got two people in a rowboat. If they paddle perfectly in sync, that's a coherent relationship, right? The boat glides forward, smooth and efficient. But if they're all out of sync, paddling at random, that's incoherent, and the boat just spins in circles. So coherence is that clean, in-sync, perfect return where nothing gets lost along the way. And the third piece of the puzzle is closure. This is the real magic. This is what locks a coherent return into a stable, self-reinforcing loop. It's like a rule is being created right on the spot. An interaction happens, and bam, it sets up a constraint that makes the outcome consistent every single time after that. This is what gives a system, like an atom or a living cell, its stable, recognizable identity. So there you have it, return, coherence, and closure. That's our toolkit. Now for the fun part. Let's put this thing to work and see how this simple little framework can just blow open some of science's biggest puzzles. Okay, first up, the arrow of time. This one's a classic. You know how at the super tiny microscopic level, the laws of physics don't really care if time goes forwards or backwards? But up here, in our world, a shattered glass never, ever puts itself back together. Time has this relentless one-way direction. So, why? Well, the rule of return just completely reframes this whole problem. Instead of talking about abstract ideas like entropy, it gives us something really concrete. Get this, when that glass shatters, all the neat, coherent relationships holding its atoms together are broken and just scattered out into the environment. To put it back together, you'd have to perfectly reverse every single one of those interactions. It's basically impossible. So time doesn't flow forward. It's just the ever-growing record of coherent relationships being broken in a way you can never undo. All right, next puzzle, quantum entanglement. You've probably heard of this one. It's what Einstein called spooky action at a distance. You can have two particles linked, and whatever you do to one instantly affects the other one. And I mean instantly, no matter how far apart they are, even across the galaxy. It seems to break the ultimate speed limit, the speed of light. So how is that even possible? Again, the rule offers this beautifully simple explanation. The particles aren't sending secret, faster-than-light text messages to each other. Nope. Instead, you have to stop thinking of them as two separate things. Think of them as two parts of a single, unified system, one coherent loop. So when you measure one particle, you're not just poking that one particle. You're interacting with the entire system at once, and that forces the whole loop to close into a definite state. Distance doesn't matter because nothing is traveling. The connection was already there, baked into the system from the start. Okay, for last puzzle, let's shift gears a bit away from fundamental physics and into biology and nature. Why is it that we see the exact same patterns, Spirals, vortices, those beautiful rosette shapes popping up over and over and over again. We see them in flowers, in seashells, even in huge weather systems. Is that all just a cosmic coincidence? You guessed it. The rule says these patterns aren't random at all. They're solutions. They're the answer to a problem. Think about it. When a system is under some kind of constraint, like a plant trying to grow towards the sun, but also having to deal with gravity and wind, it often can't just grow in a straight line. So what's the most stable, most efficient way for it to keep its internal coherence while growing? It rotates. Those spirals and rosettes, they're not just pretty, they are literally the most stable patterns a system can find to keep itself going.
Okay, I know what some of you might be thinking right now. This all sounds like a really neat philosophy, a cool way to look at the world, but for this to be real science, a powerful framework, it has to be more than that. It has to make concrete, testable predictions. You have to be able to prove it wrong. It has to be falsifiable.
And that's the thing. The rule of return isn't just a nice story. It makes hard, testable predictions. And here are 3 of them. So for instance, it predicts that what breaks entanglement isn't distance, it's noise from the environment that scrambles that coherent return. It also predicts that you can never truly reverse a complex process, like unshattering a glass. You can only create a new, different state that looks like the old one. And it predicts that those patterns in nature don't just evolve smoothly, they literally jump between stable forms when the conditions change. And here's the kicker. All of these predictions are actually being observed and tested in labs right now. So what does this all mean? Where does this leave us? Well, if this rule really holds up, it suggests a pretty profound shift in how we view reality itself. It's asking us to look past the surface of things and start seeing the relationships that actually define them. And this is the big idea, the core shift in thinking. The universe isn't just a collection of static things floating around in space. It's a dynamic, ever-changing web of relationships. What we see as an object, a chair, a planet, even you and me, is really just a stable, repeating pattern of interaction. It's a coherent loop that has found a way to stick around. There's a quote from the source material that just captures this perfectly. It says, "Existence is not persistence of stuff. It is repeatable closure under constraint. It's not about the atoms an object is made of, but its ability to keep a consistent, repeating identity over time. That is what it means to exist." So you see, this framework does way more than just explain a few weird puzzles. It's proposing the fundamental sorting mechanism for everything. It's the ultimate rule that decides what gets to exist and what just fades away into noise. And here it is, the ultimate selection rule of reality. Only returns that preserve coherence survive. Everything else reorganizes. That's the engine. Whether you're talking about physics, biology, or information, the principle is exactly the same. Systems that find a way to create a stable, coherent return get to stick around. And the ones that don't, they break down, and their parts get recycled into new patterns that can. So the ultimate takeaway here is pretty mind-bending. The universe doesn't select for things, it selects for returns that endure. We're not just looking at a universe of objects floating in space. We're looking at a universe that is constantly, relentlessly selecting for stability, for patterns that can repeat themselves, for relationships that can last through time, and that one simple, incredibly powerful idea, well, it might just be the key that unlocks everything.